In early 1942, a young engineer working for the U.S. Navy's Bureau of Ordnance made a statement to a room of high-ranking admirals that could have destroyed his professional life. He informed them their formidable battleships were fundamentally outmatched. Their main guns, the very heart of American naval power, were incapable of defeating the new enemy looming on the horizon. He warned that if they failed to act, thousands of sailors would be sent into a battle they were mathematically certain to lose. A chilling silence fell over the room. The admirals stared back, their faces like stone. One sternly told him to mind his tone. Another even suggested he be fired from the project on the spot. But the engineer held his ground. He laid out his technical drawings on the table and directed their attention to the cold, hard numbers. This was not speculation. He had performed the calculations, and the calculations were undeniable. His name was unknown then, and it remains largely obscure today. But the weapon he championed, the very one that nearly got him dismissed, would go on to arm the United States Navy for over 50 years. It would see combat across 4 separate conflicts. It would become the single most powerful naval rifle ever placed on an American warship. And it was the only weapon in the entire U.S. arsenal with a realistic chance against the most fearsome battleships ever constructed. This is the incredible story of the 16-inch 50-caliber Mark VII naval gun. It starts not in an American factory, but in a Japanese shipyard under a blanket of absolute secrecy. In the late 1930s, American naval intelligence began intercepting alarming bits and pieces of data from the Pacific. Japan was constructing something immense. Satellite imagery was still science fiction. Espionage was a game of shadows, with agents being few and often untrustworthy. Yet, the intelligence fragments continued to surface. Purchase orders for steel quantities that defied logic for any known vessel. Dry docks were being enlarged to dimensions never seen before. Shipyard personnel were forced into oaths of silence, with death as the penalty for speaking. What was Japan creating? Yamato. And when U.S. engineers finally assembled a complete picture of its specifications, their reaction wasn't professional respect, it was pure dread. The Yamato wasn't merely a large ship, she was a mobile citadel designed on a scale previously thought impossible. Her hull measured 863 feet from end to end. Her fully loaded displacement topped 72,000 tons, nearly twice that of America's contemporary battleships. Her main armor belt was a staggering 16 inches thick. Her deck armor could shrug off nearly any aerial bomb in the American inventory. She was conceived from the keel up with one guiding principle: create something so overwhelmingly powerful that no adversary would dare challenge it. But the one detail that sent shivers down the spines of American war planners was her main battery. The Yamato was armed with 9 guns arranged in 3 massive turrets. Each gun fired an 18.1-inch shell. That projectile weighed an incredible 3,200 pounds. It could travel a distance of nearly 26 miles. It was capable of penetrating the deck armor of any U.S. battleship from a range at which the American vessel could not effectively fire back. In a direct surface battle, the Yamato could destroy an American battleship before it even entered its own effective firing range. She wasn't just better, she was intentionally designed to outrange and outmuscle anything the United States could field. The Japanese naval architects who brought her to life made a very conscious bet. They understood they could never match America's industrial output in a long-term shipbuilding contest. American manufacturing power was simply too great. So they focused on quality over quantity. They conceived a vessel so dominant that its mere presence could alter the outcome of a fleet battle. She was their ace in the hole. She was their answer to America's numerical advantage. She was the weapon intended to make the whole Pacific strategic equation crumble in their favor. And the Americans were fully aware of it. The standard American battleship at the war's outset was equipped with the 16-inch 45-caliber gun. This was not a feeble weapon. It had a distinguished service history and fired a powerful projectile. But the 45 caliber gun was from a time before the Yamato was a reality. Its muzzle velocity was less, its maximum range was shorter, and its ability to penetrate armor at a distance was significantly inferior to what Japan now possessed. Against the Yamato at typical combat ranges, the physics was unforgiving. The American shells might just bounce off. The Japanese shells would almost certainly smash through. This was the dilemma facing the Bureau of Ordnance in 1942. The engineers considered every possible solution. Could they modify the existing guns? Could the projectiles be altered to hold more propellant? Could the barrels be extended? They analyzed every single variable, ran every possible simulation, and always arrived at the same conclusion. The .45 caliber gun had reached its absolute performance ceiling. The gap in capability wasn't something that could be tweaked away. It was a fundamental design limitation. If the Navy needed a gun that could face the Yamato as an equal, they would have to start from scratch. The solution was already there. It had been for years, filed away in technical archives like a dormant titan, waiting for someone to grasp its true potential. In the early 1930s, the Bureau had commissioned several experimental weapons for a long-term research initiative. Among those was a 16-inch gun with a barrel length equal to 50 times its bore diameter, 50 times 16 inches, yielding a 66-foot barrel. The additional length gave propellant gases more time to push the shell, accelerating it before it exited the muzzle. The result was a muzzle velocity of 2,500 feet per second, compared to about 2,300 feet for the .45 caliber model. That 200 feet per second difference might seem small. It wasn't. It translated into a huge increase in range, and more importantly, a major boost in the gun's power to defeat thick armor from afar. The experimental .50 caliber gun had been test-fired, its performance was recorded, and then, with no immediate use apparent, the project was shelved. Budget constraints, other priorities, and a quiet belief that no one would ever require that much firepower. They were mistaken. The engineer who dusted off those old test reports and brought them into the conference room of doubtful admirals wasn't being theatrical. He was trying to avert a disaster. He had compared the .50 caliber design's performance against the Yamato's known armor values and discovered something that forced him to pause. At combat ranges, given the right circumstances, the .50 caliber Mark VII could punch its armor-piercing projectile through the Yamato's belt. Not with ease and not at the furthest possible range, but in a real fight, the weapon was competitive where the .45 caliber simply was not. So, what did the admirals do? They didn't fire him. They heard him out and then posed the one question that would shape the next phase of American naval history. What ship can handle it? This was not a simple inquiry. The Mark VII gun wasn't just a bigger barrel, it was a larger system in every single respect. One gun barrel alone weighed 143 tons. The complete three-turret turret, including the barbette, the armored enclosure, the loading machinery, the ammunition handling rooms extending down several decks, and the powder magazines, all of it together, weighed almost 1,700 tons per turret. That much mass demanded a hull of immense structural integrity. It needed a beam wide enough to maintain stability when all three turrets fired a broadside, an event that sent a shockwave through every plate and weld. It demanded a completely different level of engineering. The Navy reviewed its existing battleship classes and dismissed them one by one. The older vessels didn't have the necessary displacement. The South Dakota class was getting warm, but still not enough. There was only one possible candidate, the Iowa-class. The Iowa-class battleships were authorized in 1938 to be the largest, fastest, and most powerful surface ships in American history. They were conceived with speed as a core requirement, capable of over 32 knots, quick enough to escort the aircraft carriers that were fast becoming the new center of naval power. Their hulls were 886 feet long, their beam at the waterline was 108 feet, their displacement was over 45,000 tons, and crucially, their internal layout was conceived with the foresight of accommodating a heavier main armament. They were the only ships in the pipeline that could carry the Mark VII.
Construction was already underway when the final decision was made to incorporate the new gun. This sparked engineering challenges that pushed the Bureau's resourcefulness to its limit. The barbette foundations needed to be completely re-engineered, the ammunition hoists had to be reconfigured, the fire control systems, the optical rangefinders, the mechanical computers that generated firing solutions, the director systems tracking targets and sending data to the guns. All of it needed to be redesigned around a weapon whose parameters had shifted. Workers who had already laid down steel had to tear it out and begin anew. Blueprints that had been finalized and approved were scrapped. Delivery timetables promised to anxious naval commanders were extended. The managers tasked with keeping the Iowa-class build on schedule had the unenviable duty of telling admirals why their ships would be late. The reason was always the same, because you wanted the bigger gun. And the admirals, to their great credit, accepted this. They knew that showing up on time with the wrong weapon was far worse than arriving late with the right one. A delayed victory is better than a swift defeat. The Mark VII's armor-piercing shell weighed 2,700 pounds. To put that in perspective, a modern compact car weighs about the same. The Navy was asking its sailors to load a car-sized projectile into a gun breech, follow it with multiple silk bags of powder weighing hundreds of pounds, close a breech block as large as a refrigerator, and perform this entire sequence quickly enough to sustain a practical rate of fire. 2 rounds per minute was the goal for a skilled crew. Hitting that target required an astonishing degree of mechanical sophistication. The loading process involved a mix of hydraulic rammers and expertly designed powder handling gear to manage the immense weights. The shells were kept on rotating projectile rings deep inside the ship, lifted to the turret via powered elevators, shifted to the loading tray by hydraulic arms, and then rammed home by a mechanism strong enough to shove nearly 3,000 pounds of steel into a tight chamber. Every single part of this system had to be perfectly timed, synchronized, and durable enough to work in the chaos, heat, and vibration of combat. The propellant was just as complex. The Mark VII used a divided powder charge made of 6 separate bags of smokeless powder. Each bag weighed around 110 pounds. The bags were handled individually, loaded into the chamber behind the projectile one by one, and then the breech was sealed. The full charge, upon ignition, created pressures inside the barrel that exceeded 20,000 pounds per square inch, launching the 2,700-pound shell from a dead stop to its muzzle velocity in a tiny fraction of a second. That muzzle velocity of 2,500 feet per second meant the shell exited the barrel before the sound of the blast could catch up. By the time the gun crew heard the report of their own weapon, the projectile was already a mile away. And that shell, once airborne, flew in a majestic arc over distances that are hard to fathom. At its maximum range, it soared to an altitude over 33,000 feet at its trajectory's apex, higher than many commercial airliners fly today, before plunging back toward its target in an almost vertical dive. The angle of this final descent was key to what made the Mark VII so dangerous to armored vessels. A shell arriving from nearly overhead would strike the thinner deck armor rather than the much thicker belt armor on a ship's sides. Against the Yamato's formidable side protection, the challenge was immense, but against its decks, even with her high protection levels, a well-aimed Mark VII round was a grave threat. The barrel was an absolute masterpiece of metallurgical science. Its 66-foot length was constructed from concentric steel tubes, shrunk fit together under incredible pressure, with each layer contributing to the tube's overall strength. The rifling carved into the bore, the spiral grooves that spun the projectile for gyroscopic stability in flight, ran the entire length of the barrel with a twist rate calculated for optimal accuracy at the gun's intended range. The barrel had a rated service life of approximately 300 full-charge shots before its accuracy would degrade enough to need replacement. After 300 rounds, the rifling would be worn down in key areas, and a fresh barrel had to be installed, a complex procedure requiring special equipment and a shipyard visit, taking it away from the fight. The engineering behind these mechanical fire control computers is a story in itself. For now, what's important is that they worked. When a proficient fire control team on an Iowa-class battleship fed accurate data into the system and the Mark VII guns fired, the shells landed where they were aimed. At battle ranges of 10 to 15 miles, a skilled crew could achieve a dispersion pattern tight enough to endanger any vessel afloat. The first Iowa-class ship to enter service was the USS Iowa in February 1943. The USS New Jersey followed in May.
The USS Missouri was commissioned in June of 1944, the USS Wisconsin in April of that same year. 4 ships, 4 platforms for the most powerful naval guns in American history. And then, the epic surface clash with the Yamato that had driven this whole effort never materialized. This is the central irony of the Mark VII story. The gun was created to fight a single enemy in a very specific type of battle. 2 fleets of battleships closing range, exchanging salvos until one side could no longer fight. That battle never happened. The Pacific War was ultimately won by aircraft carriers, by overwhelming air power, by submarines, and by the relentless logic of American industrial might. By the time the Iowa-class ships deployed in force, the Yamato fleet had been crippled at Midway and in the Philippine Sea. The Yamato herself met her end in April 1945, not from battleship guns, but from American carrier aircraft that struck her with 5 bombs and 10 torpedoes before she ever got close to a surface engagement. The engineers who designed the Mark VII to beat the Yamato never saw their weapon tested in the very fight it was made for. But war has little regard for the plans of engineers. What did the Mark VII get instead? Shore bombardment. And in that new role, it revealed itself to be something the Navy hadn't fully appreciated, a weapon of extraordinary, almost terrifying power against land-based targets. Using battleship guns for shore bombardment was not a new idea. Navies had been pounding coastal forts for centuries, but the sheer scale and precision of what the Iowa-class ships could achieve with their Mark VII guns was on another level entirely. A high-capacity shell fired by the Mark VII weighed 1,900 pounds and carried a bursting charge of 154 pounds of high explosive. When this shell hit its target after a flight of 20 miles or more over open water, it was still traveling fast enough to burrow deep into reinforced concrete before it detonated. The resulting blast radius was enormous. The penetration against bunkers and fortifications was superior to anything else in the American arsenal that could be delivered from a safe standoff distance. During the island-hopping campaigns in the Pacific, Iowa-class ships used their Mark VIIs to systematically obliterate Japanese coastal defenses ahead of amphibious landings. The Marines who stormed those beaches knew what the battleship guns had done for them. The enemy strongpoints that could have mowed them down in the water were now rubble. The gun positions that could have stalled an advance for days were driven deep into the coral by shells arriving without warning at supersonic speed. A weapon's true worth is found in its use.
The war concluded in September 1945. The battleships returned home, and most of the Navy's other battleships were put out of service, their utility in the carrier age seemingly at an end. But the Iowa-class remained. Their unique blend of speed, firepower, and survivability was simply too valuable to throw away, even in a world where airplanes had replaced guns as the primary naval weapon. The wisdom of that choice became evident in June 1950, when North Korean forces surged across the 38th parallel, and the United States was once again at war. The Iowa-class battleships were brought back. The USS New Jersey, the USS Missouri, and others returned to the fleet and sailed for Korean waters, where their Mark VII guns played the same role they had in the Pacific, destroying fortifications, suppressing enemy artillery, and delivering a volume of fire no other naval asset could hope to match. The accuracy was still there. The destructive power was undiminished. The guns operated precisely as they were intended, and the soldiers and Marines on the ground calling for naval gunfire support were thankful for every single round. There are accounts from forward observers on Korean hillsides describing calling in a fire mission and watching the shells arrive moments later, sounding like a freight train screaming overhead, followed by an explosion that shook the ground for hundreds of yards in every direction. Enemy units entrenched on ridgelines for weeks were shattered and forced to retreat after just one sustained barrage from an Iowa-class ship sitting offshore. The 16-inch gun didn't just demolish physical targets, it demolished the enemy's will to hold a position. The Korean War ended with an armistice in 1953. The battleships were mothballed again, kept in reserve for over a decade, preserved for a future conflict.
That need arose again in the mid-1960s as American forces became deeply involved in Vietnam. The USS New Jersey was recommissioned in April 1968 and sent to the waters off Vietnam, where she ran shore bombardment missions along the coast in support of ground troops. In under a year of service, she fired almost 6,000 rounds of 16-inch ammunition. The psychological effect on enemy units operating near the coast was immense. The physical damage was total. Structures, supply lines, and defensive positions that had endured airstrikes were completely obliterated by the sheer weight and penetration of shells, arriving at speeds and angles no bomb could match. The New Jersey was decommissioned once more in 1969. Political and budget pressures in the post-Vietnam era seemed to mark the final end of the battleship. For more than a decade, the Iowa-class sat dormant. Most experts believed they would never sail again. They were wrong once more. In the early 1980s, the Reagan administration initiated a massive naval expansion program aimed at building a 600-ship navy to counter Soviet maritime influence. The Iowa-class battleships were a key part of that plan. All 4 ships were recommissioned between 1982 and 1988, updated with new sensors, communications gear, and cruise missile launchers that gave them a strike capability their original designers could never have dreamed of. But the Mark 7 guns stayed. They stayed because nothing developed in the 40 years since could do what they did. The Mark 7's final combat role took place in the deserts of the Middle East. Operation Desert Storm, the coalition effort to liberate Kuwait from Iraqi occupation, started in January 1991. The USS Missouri and the USS Wisconsin were deployed to the Persian Gulf. Their Mark 7 guns were used to hit Iraqi coastal defenses and military sites. But the most important contribution the battleships made in that war was something unforeseen. The Iraqis, knowing the battleships were just over the horizon, had no idea where they might strike next. The threat of the guns pinned down Iraqi forces in coastal defensive postures, tying up troops and armor that couldn't be moved inland for fear of what those massive guns could do. The 2 battleships effectively immobilized a huge part of the Iraqi coastal defense force just by being there. When the guns did open fire, the effects were immediate and devastating. Iraqi artillery batteries that tried to fire back were silenced. Bunkers designed to survive conventional air attacks were breached, a command post was destroyed, and throughout it all, the guns that were conceived in the 1930s to fight a Japanese battleship, a ship sunk by aircraft before it ever saw an American surface combatant, were still performing their duty, still delivering a weight of fire that nothing else in the fleet could equal. The Wisconsin fired her last Mark 7 round in combat in February 1991. The Missouri fired hers soon after. When the ceasefire was announced and the ship sailed for home, they carried a service record that spanned almost 5 decades, 4 wars, and 3 generations of American sailors. They were decommissioned for the last time in 1991 and 1992, preserved as museum ships around the country, where people can now walk their decks and stand beside the enormous breaches of guns that once made admirals debate the very nature of what was possible. If you enjoy stories about incredible military history like this one, please consider leaving a like and subscribing to WWII Record Hub. The Mark 7 was never used in the battle it was made for. The duel with the Yamato, the great surface clash in the Pacific that engineers and strategists designed it to win, that fight never came. But the weapon survived long after the Yamato was gone, and the Japanese fleet was a memory. It survived because the very qualities that made it a terror against a steel warship, its range, its precision, its devastating ability to penetrate steel, translated perfectly into qualities that made it equally terrifying against everything else. The young engineer who laid out his diagrams on that conference table in 1942 and told a room of admirals their ships couldn't win was not incorrect. He was right about the gun. He was right about the threat. He was right that small fixes and adjustments would not be enough. The admirals who nearly had him removed were likely thinking of careers, politics, and the sheer inconvenience of hearing difficult truths from a subordinate. but they chose to listen anyway. And what they received was a weapon that outlived the war it was designed for, outlived the enemy it was meant to defeat, and outlived the era of the battleship itself. The Iowa-class is no longer in active service. The Mark VII guns have been silent in combat for over 30 years. But if you stand at the breach of a turret aboard the USS Missouri in Pearl Harbor and gaze down the length of one of those guns, 66 feet of rifled steel, 143 tons of precision-engineered metal made to hurl a car-sized projectile over 20 miles with enough accuracy to hit a building, you feel it. Designed by engineers who refused to believe a problem was unsolvable, built by workers who had never made anything like it, tested against all expectations and exceeding them all, carried into battle by sailors who believed the weapon above their heads was worth the wait. It was. It always was. The gun that was almost never built, championed by the man they almost fired for demanding it, spent half a century proving its worth. Some weapons define an era. Others outlast the era they were made for. The 16-inch 50 caliber Mark VII did both. It was the solution to a threat that was already obsolete by the time the gun was ready, and yet it still found a way to matter, decade after decade, war after war, until the Navy finally ran out of wars for it to fight.